Hi, algebra friends. These are your notes for section 6.2 on exponential functions. So far this year, we've been looking at linear functions and talking everything linear. So we're going to look at a new function today called an exponential function. And we're going to start with graphing. So notice it says graph each function using the indicated values on the table. Identify the y-intercept, the domain, and the range. So domain and range are going to be two new pieces of vocabulary today that we're going to talk about. Also, you probably see those words growth and decay. So we'll discuss those as well as we move through this first part of the lesson. To begin, let's just remember that anytime we want to graph a function, whether it's a linear function or an exponential function or any other kind of function, we can always create a table of values. So that's why we've chosen to do that. So notice we've already decided on our x values, and we always want to pick small x values, so those are easy to plug into the function and evaluate. So I'm going to start there. So our first x value is -3. So this is, remember, we worked a little bit with evaluating negative exponents recently. So 3 to the -3rd power is the same as 1 over 3 cubed, which is 1 over 27. So make sure you stop and think about how to evaluate those negative exponents. 3 to the -2nd power is the same as 1 over 3 squared, which is 1/9. 3 to the -1st is 1 over 3 to the 1st, or 1/3. Remember, any number to the 0 power is 1. And then 3 to the 1st is 3. 3 squared is 9. 3 cubed is 27. Okay, so anytime we're graphing an exponential function, if we wanted to write down some steps, step 1 would be to complete a table of values. Excuse me. Step 2 is going to be to plot the points on our table. Okay, now remember, we're not going to be able to exactly plot these first few points, like -3, 127. So we just kind of ballpark those. We know that it's going to come really, really, really close to the x-axis, but it's not going to touch. Same thing with 1/9, probably just ever so slightly higher, and then 1/3 maybe about right there. And then we can start actually seeing this function take formation. So these points are going to be moving upward from the left to the right. Here's 1/3. Here's 2/9. And then you'll notice we can't fit that last point on the graph, and that's okay. We don't need all of those points on the graph. So if you can't fit 1 or 2 on the graph, that's totally fine. So we just do the best we can. Now, here's the important part. So you want to take a look at that. First, you want to notice that those points are not in a linear path. They are forming a curve. So our next step is going to be to draw a smooth curve. Whoops. Okay, so when we draw our curve, this curve is never ever going to cross that x-axis. So it's going to kind of start down there, and it is going to curve upwards. And technically, it should have an arrow at both ends, reminding us that that function is going to continue on, never ending in both of those directions. So let's talk about a couple of other things about this function. It has a y-intercept of 0, 1. And let's talk about our new vocabulary, domain and range. So the domain of a function are the values from left to right, okay? So on this function, it's basically our x values. So we're going to write this in here. The domain are the x values. Now, because we have an arrow here and an arrow here, that function is going to continue moving, never ending in both directions. And so this one is all real numbers. Okay, usually we write that as a capital R with that double line. You'll see as we go through. Capital R just means all real numbers. In fact, I'll kind of redo that for you. So here's all real. And when we talk about range, range is our y values. Okay, y values are top to bottom. So when you look at this graph, okay, you want to see where is this function going from the top to the bottom. Well, as I mentioned, it's never ever going to cross that x-axis, but it is going to continue moving, never ending in this direction. So it's going to keep going. So for our y values, we just say the range or all the values of y that are greater than 0. Notice I didn't say greater than or equal to because it's never going to equal 0. It's just all the y values greater than 0. All right, here's new vocabulary as well. Growth in decay, A growth is a function, an exponential function that rises from left to right. So this one is a growth function. Let's write that vocabulary over here really quick. Okay, so the graph rises from left to right. So just like it says, that function is growing exponentially. And of course, a decay is the opposite of that, and we'll see that in a few minutes in one of these other graphs. A decay is a graph that falls from left to right. Okay, so you might have heard these terms used in a real life situation like my money is growing exponentially. So when you invest money in something and you're earning interest on that money and it's earning, you just leave it sit in the bank and it's growing money over time. So that money is growing exponentially. We can also, unfortunately, money can decay over time. So if you're losing money at an exponential rate, then that's a decay when you're losing something. So we're going to continue talking about this as we move on. All right, let's look at this next one. So -3 is our exponent. I'm going to move hopefully a little bit quicker here. So 1/2 to the -3rd. Okay, so let's go over here again and kind of take a look at this. Sorry, that was not a negative number, just 1/2 to the -3rd. Okay, when you evaluate with negative exponents, the rule is you take the reciprocal of the base and the exponent becomes positive. So it's 2/1 to the 3rd power, or just 2 cubed, which is 8. Okay, and then we have 1/2 to the -2nd would be 2/1, or just 2 squared, which is 4. And then 1/2 to the 1st is just 2. Anything to the 0 power is 1. And then that gets a little easier from here. 1/2 squared is a half times a half, or a fourth. And then a fourth times a half is 1/8. Okay, so let's go ahead and graph this function. So if you look at our points, we have -3, 8. Our next point is -2, 4. -1, 2. 0, 1. 1/2, which we can plot. 2 1/4, which we can kind of plot there, and then obviously it's going to get a little trickier. So let's draw our smooth curve through these points as best you can. You want to connect all of your points, and again, remembering that we want an arrow on each end to show that that function is never ending in all directions, or I should say in both directions. And we want to look at a couple of other things. So our y-intercept for this graph is again 0, 1. Domain, because those values left to right on the x-axis are going to continue never ending in either direction. The domain is all real numbers. And our range is, again, y is greater than 0. Okay, so let's look at our graph. This one falls from left to right, so this one is a decay function. Like we talked about, this graph falls from left to right, so you can see it's facing in the opposite direction of the first graph that we did. All right, let's look down here. First of all, just to clarify, these little boxes should be multiplication signs. So number 3 is 1/2 times 4 to the x is our function. So let's evaluate this. So again, looking over here, I'll do some scratch work. So we have 1/2 times 4 to the negative third power. So 4 to the negative third would be 1 over 4 cubed, which is 1/64th. So it's 1/2 times 1/64th, which is 128, which obviously is never going to fit on our graph. So then we have 1/2 times 4 to the negative second. Okay, so 1/2 times 1 over 16 is 1 over 32. 2 times 16 is 32. And then 1/2 times 4 to the negative first is 1 over 4. So that's 1/8. Then it'll get easier from there. So 4 to the 0 power, you have to remember order of operations here. So notice I've been evaluating this part of the function first and then multiplying by 1/2 because exponents come before multiplication. So 4 to the 0 power is 1. 1 times 1/2 is a half. 4 to the first power is 4. Half of 4 is 2. And then 4 squared is 16. Half of 16 is 8. And then 4 cubed is 64. Half of 64 is 32. Let's try to go ahead and graph these. Again, you cannot fit that first one on your graph. Obviously, this next point is, these are both very, very close to the y-axis. 0, 1/2 is about right here. And then we have 1, 2, 2, 8. And then, of course, 332 is not going to fit on there as well. So I'm going to draw my smooth curve through those points. Okay, kind of missed that one there, but that's okay. Draw your line, your arrows at both ends. My y-intercept on this one, also remember, an easy way to remember that is the y-intercept is the point at which x is equal to 0. So it's 0, 1/2. Okay, domain is, as you can see, is going to be all real numbers again, and y is greater than 0. All right. We've got one more function to look at here, and this one is similar. This one is 2 times 1/3 to the power of x. Okay, so let's take a look at this function and start with 2 times 1/3 to the negative third. So remember, we're going to do the reciprocal of the base. The reciprocal of 1/3 is 3. And that's, exponent becomes positive. So 3 cubed is 27. 2 times 27 is 54, right? 7, 14, 50, yeah. Okay, and then 2 times 1/2 to the negative second. We take the reciprocal of the base, and the exponent becomes positive. And then again, evaluate your exponent first. 2 squared is 4, times 2 is 8. The next one, 2 times 1/2 to the negative first becomes 2 times 2 to the first. 2 to the first is 2, times 2 is 4. Okay, should hopefully get easier from here. Oh, darn it, I did a half instead of a third. I got to go back and fix my math, guys. Shoop. That first one is correct. The second and third one are not. You probably caught that before I did. So let me fix this really quick. 1/3. So that'd be 3 squared, which is 9, times 2 is 18. And then we would have 1/3 to the negative first, which would just be 2 times 3, which would be 6. Sorry about that. Okay, 1/3 to the 0 power is 1, times 2 is 2. 1/3 to the first power is a third. 1/3 times 2 is 2/3. 1/3 squared would be a third times a third, which is 1/9. 1/9 times 2 is 2/9. 1/3 cubed is 1/27th, times 2 is 2 27ths. Okay, so I'm going to plot my points. Again, I cannot plot my first point, -354, nor can I plot -218. So it looks like I'm going to start with -1, 6. That's right here. Then we have 0, 2. Then 1 2/3. About right there. You're just kind of ballparking these points that are really, really, really small. Okay, and then I'm going to go ahead and draw my smooth curve through my points. Okay, so let's look at a couple of things. My y-intercept, again, is the point at which x equals 0. So I would say that is 0, 2. My domain, again, is going to be all real numbers. And my range is y is greater than 0. Okay, it looks like I forgot to discuss growth or decay on that last graph. So hopefully you've figured out that that one is a growth because the graph rises from left to right. On the other hand, this one is a decay because the graph falls from left to right. Okay, so before we move on, I want to talk about a couple of things. I'm probably going to have to make a video of the second half because this might take a few minutes, but let's look at some important aspects of these functions. So the first thing I want to talk about is our y-intercept, okay? So when there is no value in front of the exponential portion of the function, like in number 1 and number 2, notice the y-intercept is always going to be 1. Okay, that will change when you start multiplying that exponential function by a number. So down at the bottom, notice that changes. The other thing I want to talk about is, let's see, we've talked about growth and decay. Let's talk about domain and range. So can you see that the domain and range is potentially going to be the same for all of these graphs? The domain is always going to be real numbers. The range is always going to be y is equal to 0. For right now in this lesson until we start doing a couple of other things with this particular graph. All right, let's also talk about what causes a graph to be a growth or a decay. Okay, so when you look at that value, actually, I'm probably going to have to come back to that because we haven't talked about the formula yet. So let me come back to that thought in just a minute, and we are going to talk about one more vocabulary word, and that is asymptote. Okay, the asymptote of an exponential function is the line. It's basically the line that the graph is approaching but not equal to. So for example, in all 4 of these graphs, the asymptote would be y equals 0. Okay, so it's the horizontal line that the function is approaching but never, ever, ever touches or crosses over. Okay, so it's kind of like the boundary line of your exponential function. All right, so I'm going to stop there. I think we're just doing graphing today, and then I will do a second video which covers the second half of our lesson.